My name is Balaji C. Today we are explaining of ADF achievement of half wave rectifier, full wave rectifier and PN junction and forward bias and reverse bias. Our teammates are Balaji C, Akshay Kumar PR, Gautam MM and Hareesh CV. I am going to explain of forward bias. The forward bias process the connection of diode P type on side of positive terminal and voltage sources N type sides of negative terminal. The the forward bias is the virtual connection between the electricity. This setup reduces the width of the depletion of layer, enabling majority charges carriers, holes of p side and electrons are the n sides to cross the junction and conduct an electric current. The connections are positive terminal external voltage source connected in the p-type materials are called as anode. The negative terminals connected between the p-type materials is also called as cathode. The overcoming barrier are the applied external voltage opposes the internal barrier of the PN junction. For the silicon on the germanium, it's about 0.3 volt. Depletion of layer reduction as the applied voltage increases, it pushes the majority of the charge carrier toward the junction, effectively shrinking and deflection of the reducing of potential barrier. The current flow of the forward bias are the
ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಹೇಳ್ರ.
it's in the largely eliminated and large current flows through the diode. The majority of the barrier now able to easily across the
ಏ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಹಾಕೊಂಡ್ ಬಲಜಿ.
junction. Low resistance forward bias diode act as a low resistance for the current and the forward bias is ಹೇಳಲೆ ಅಕ್ಷಿ
Net reverse bias is a condition in a semiconductor diode where an external voltage is applied in a direction that opposes the natural flow of majority charge carriers, significantly increasing the device's resistance and effectively blocking most of the current. The diode acts as an open switch in this state. A diode RN PN junction is reverse bias when the negative side of external bias voltage is connected to the P region of the diode, the anode in a diode, and the positive side is connected to the N region, the cathode in a diode. In this condition, the current can't flow through the PN junction. Reverse bias is a condition where the p-type semiconductor of a diode is connected to the negative terminal of a voltage source and the n-type semiconductor is connected to the positive terminal. Allows engineers to design circuits that utilize diodes for rectification or signal processing while ensuring that undesired currents do not interfere with, and solar cells use reverse bias to create a large depletion region, allowing them to efficiently detect light or convert light energy into electrical energy. Uh, Temperature at high temperatures, more minority carriers are generated thermally, increasing the leakage current. Junction area, larger junction areas result in higher currents as there are more minority carriers available to diffuse across the depletion region. In contrast, while in reverse bias, we connect the positive terminal of the voltage supplied to the cathode and the negative terminal to the anode, while in reverse bias condition RF PN junction diode is described by the same diode equation as a positive voltage applied. The total current where IS is the reverse saturation current, V is reverse voltage, and N is ideal factor, and Vt is the thermal voltage. In reverse bias, the exponential term is very small, so the equation simplifies to nearly construct a reverse saturation current. Reverse bias has several practical applications in electric circuits, photodiodes, and solar cells. Next part will continue by Arish CV.